and I've been with the company since 2006, and have worked with most of the engineering community here in Ontario since that time, assisting with helping with product selection and working on sizing and so forth. So anyhow, thank you for joining us. And I wanted to today's topic was to review the electric water heater line that we have, and uh, the reason for why I think this seminar is important for everybody is a lot to do with our Canadian government, National Resource Canada, uh, making this commitment to having net zero emissions by 2050. And I think everybody has heard this, and our government has deemed that electric water heaters are a path for us to achieve those net zero emissions by that time. There's another goal that I didn't put on here, but by 2035, Canada is committed to reducing our carbon to by reducing it, like I think it's 45% by 2035. So we're already seeing this in parts of Canada where electric has become the choice, and like in Vancouver area, new developments aren't even getting gas lines installed anymore in their communities. So we're seeing that. So residential heat pumps are increasing in popularity, and I want to talk about those. And I think you're going to see a lot more seminars on this product line, how they can fit your applications commercially and residentially. So on this slide here at the bottom, when you do get a copy of this presentation, feel free, please click on those links. They'll take you to some discussions about where we're going as far as how electric water heaters can affect our climate change and meet the Canadian targets. So right with that, I just wanted to clarify our website, www.hotwatercanada.ca. We have hotwater.com, which is our US site, and I just want to caution, some of our sites, we have them all over the world, and not all that product is available in Canada. So everything that we have to offer is hotwatercanada.ca, and we just updated our website. It's new, and it really has all the same tools, and I just think it helped organize things and put it in a nicer way. But when you go to our website, you have our commercial sizing and selection program. That is a fantastic tool. We use it as much as possible. So if you haven't been on one of our seminars in the past, we have done sizing seminars and used some examples of it. I do want to say that it covers pretty much 80% of the applications, but there are some situations that you may want to consult with ATS. Or myself here at A.O. Smith. There's myself, Will Kublis, and we have Debbie Shortreed as well in our organization, that is application specialist, and we can also utilize our engineering team that we have. So there are some situations where maybe you're working on an office building that has a restaurant and a gym in it or something, that maybe the application program doesn't cover. That's something that we would help assist with. There's also, for anybody that's doing residential water heaters for, like, say, custom homes, we have on that program a residential product selection program, and this is something that I usually try not to guess at. I send the link to the homeowner, the person that is going to be utilizing the home, and get them to answer the questions and let them figure it out, because only they would know how many showers they want to have back to back and so forth. So and what size bathtubs and how many people live in the home and so forth. So it's good to share that link. So if you are working on a residential home, please look for that on our website. It's in the residential section. We have a water heater cross-reference from one brand to another. All our installation manuals, spec sheets, piping diagrams are all on our website. So basically, you're going to drill into like the product that you're interested in. In the case, you would click on commercial electric, and you will see the product, and you can drill down and get piping diagrams, installation manuals. We have Revit tool there. All of the 3-part specs are there as well. They're all written up for you in Word document. We have product videos and training videos. So if you're not comfortable with, say, our commercial heat pump or a residential heat pump water heater, we do have videos on there. They're like a YouTube short video that is very informative. So with that, why we're here, and the electric benefits, and we've been building electric water heaters like right from the very beginning of age here, and in some cases, you had no choice but to use electric water heaters because you didn't have a way to vent a gas water heater out the side of a building properly, maybe it was difficult to run a gas line there. So electric has always been popular, but it's gaining more popularity because of these electrification requirements by our government, there's like as I said already, our municipalities can come along and just say, sorry, we're not putting gas in any longer, only electric. So that could happen, I believe, at any time. So, but with electric, there's no individual greenhouse gas emissions, and I know that's an argument that we could all have about the generations of electricity, but generally. Building our electric from one source, wind power and solar is definitely reducing greenhouse gas emissions. We have our electrics all have very high recovery rates and storage volumes for all demands, as you'll see. As I mentioned, no venting is required. You can locate these anywhere where you have power supply. And there's other benefits as well. I believe there's less maintenance requirements for an electric water heater. There's really no moving parts, no blower motors, no flame rods that need to be cleaned and so forth. So there is that benefit aspect as well. And we do also have building management systems available for select models, which I'm going to show you here today. And so just I wanted to just clarify the most important term here that I find is the kilowatt. So we use that term quite often. So all our water heaters here in Canada, and the reason why you want to Canadian site is that our spec sheets show all of our Canadian voltages. So 600 volt is not available in the US. So if you're on a US site and download their spec sheet, you won't see the option for 600 volt there. So on our Canadian spec sheet, it does show the specs at 600 volt power supply. But basically, kilowatt is like our horsepower. So the greater the kilowatt, the more horsepower or the more heating ability. So I tend to use 1 kilowatt. I just use this number quite often. 1 kilowatt will heat 4.1 gallons of water 100 degrees at a time. So like a 3 kilowatt water heater, which is typical of a residential water heater, I would take 3 kilowatts times it by 4.1, and that heater is going to heat about 12 gallons of water an hour. So a 40-gallon tank is going to take a little over 3 hours to heat. All our discussions, all our spec sheets are in US gallons or liters. So I do find that sometimes can get confusing. I always have to ask the customer, is it US or Canadian imperial gallons? So we use US gallons. And if you needed to convert a gas water heater to electric, the conversion factor is 1 kilowatt will heat or is equivalent to 3,413,000 BTUs. So there is a simple formula for figuring out if anybody asks me, well, I need 100 gallons of water an hour, I only have to raise the temperature 10 degrees. Then there's the formula up there to calculate how many kilowatts you would need to do that with the water heater. So
just a quick interruption. Well, I just wanted to let everyone know, if you have any questions at any point, please just use the Q&A option, the chat option, and we'll be more than happy to answer your questions live during this presentation.
Sure. Yeah, would you please interrupt me, Mo, because I don't know if I'll see the questions on my screen, but
yeah, I will.
Okay. So they're just I broke our product down residentially and commercially. The residential product line, it's used commercially because they're just limited capacity. They're meant for residential type of job, like in a house that has 4 people or whatever. So they do tend to limit, I think 6 kilowatts is our maximum elements that we would put in there. So as I said, 6 kilowatts times 4.1, they're going to heat 24 gallons of water an hour roughly. So quite often I know several engineers will specify our space savers. They are short and stocky, and there's nothing wrong with specifying residential and commercial applications. I do want to let you know, in the warranty description, it does say residential product used in commercial applications default to a 1-year warranty. They're meant like for, as I said, residential use, and that's how we price them, and they should still last just like any other water heater, but they're just limited capacity. So space savers are quite common in our world here. The little 2.5 gallon wall hung plugs in, and I'm not going over the details of these residential because this is a commercial program, but just to make you aware that you'll see those products there, and the little space savers are ideal for that shipping office down the back of the warehouse where they have a bathroom and a hand sink, type of thing. So they're quite often used there. We have the 3 models of electric tankless on the residential side, up to 18 kilowatts. So just to give you an idea of an electric tankless water heater, an 18 kilowatt unit at 240 volt requires a 100 amp breaker, and it will deliver, if you do the math of making my formula, it will heat 1.2 gallons of hot water a minute at 100-degree rise. So that basically limits them to 1 shower, so or a couple of hand sinks. And it's important to make sure that you put them on controlled faucets, meaning that if it's like on a mop sink and the person goes and opens the valve on a mop sink, it will only heat 1.2 gallons of hot water a minute, and if they flow 8 gallons a minute, it'll come out cold. So it needs to be on a flow control. And then we also have our standard 50 and 80 gallon residential electrics. And there is 3 models of a heat pump residential water heater, which are gaining quickly in popularity because of this whole topic. So commercially, down at the bottom, I wanted to kind of show what the difference and helping you make the right choice of the type of controls and so forth. But starting over on the left side are light duty electric. Yes.
They're just asking if you can increase the volume up a little bit, and
I'm sorry.
There's another question regarding if there's a significant difference between commercial and residential water heaters in terms of functionality, and why some contractors put residential hot water heaters in commercial spaces.
Yeah, okay. If I move over and speak a little louder, does this make any difference? Like I'm closer to my mic now?
I think so, yes.
Yeah, okay. As I was saying, residentially and commercially, the biggest real difference between a residential water heater and a commercial is really the heating and size, the capacity of its ability to heat. So residentially, the largest kilowatts we have is 6 kilowatts in a tank type water heater, and that's it. So when you need more than that, then you definitely need to switch over to a commercial water heater. As far as like tank construction and so forth, there's you know, our largest residential water heater is 80 US gallons. So you need more than, and you need to definitely switch over to a commercial water heater. But as far as like the steel and all of that other stuff, they're very similar. I believe, you know, like I don't know the details of the gauge of the tank or anything, but the gauge steel and whatever, but they're all built to last. Typically, a residential water heater in our Canadian, or should say in our Toronto market, will last 12 to 14 years. And it would last longer if people maintained them and changed anode rods and controlled pressures and so forth. They get good life out of them. And I'll talk a little bit about the life down at the very last slide here. So hopefully you can stick around for that. But I hope I answered that. So you'll see. So we have our space savers, and if you're doing like a small water heater for a shipping office bathroom down the back of the warehouse, you know, we do have our commercial Dell models, and you'll see there on the bottom left, there's a 6 gallon model, and they go up to 120 gallons, and they are limited to up to 12 kilowatts. I'm going to talk about our heat pump. Moving over right wise there's our general duty electric. We make kind of 50, 80, 119 gallon. You'll see they go up to 54 kilowatts now. We have our sanitizing duty electric, same as the general duty, but they have a different control. I'm going to talk about that. Our heavy duty industrial ASME tanks, 5 to 119 gallons. You'll see they go up to 90 kilowatts. All of those tanks are stock in Fergus, generally as a rule. Moving to the very right, we have our custom, I'm going to say build to order. They're really, we can customize them as well, and you'll see that we go up to 2,500 gallons and up to 900 kilowatts. So we have quite a range that should satisfy all of your any type of application. I wanted to talk about the difference between surface mounted and immersion thermostat. So the immersion thermostats are generally models that have the LCD screen on them. And what's really different about them? So the surface mounted thermostat mounts on the tank, on the outer skin of the inner tank. It is adjustable, will go up to 180 degrees, but it does not have an adjustable factory differential. And what the differential is what temperature roughly is this tank going to start heating back up again. So let's just take an example. Water is not used from 6 o'clock at night till 7 in the morning. And the tank sits there, it's all heated up. It's say it's sitting at 180 degrees. And then overnight, the tank temperature slowly drops and drops and drops. Well, at what temperature will it click back on at? That differential is not adjustable with surface mounted thermostats. from what I understand from the manufacturers of the thermostats, they can drop as much as 15 degrees before they tell the tank to heat back up again. So at 180 degrees, that tank could essentially drop to 165 before it tells it to start heating back up. So my saying is surface mounted thermostat water heaters are ideal for general purpose hot water, where as long as you put your hand in the water and it's hot, like for showers, mopping floors, all that sort of stuff, then it's a great water heater for you. Sensing each element in our commercial water heater has its own T-stat, and there is a manual high limit reset button on each one of these thermostats as well. So like in a situation where we just had somebody installed a water heater with the surface mounted thermostat, and they were questioning, why does it take like 2 to 3 minutes for it to turn on? And you got to think that's the tank's hot, and then they exhausted the tank, replaced it with cold water. Well, it takes a few minutes for the actual tank to even transfer the cold water through the steel to the thermostat to tell it to turn on. So they're not really accurate, is what I'm trying to say. They do a great job. They're simple, inexpensive type of control. So immersion thermostats, on the other hand, the probe is right in the water vessel. It's sensing the water the actual water temperature, so they're very quick to respond. They have an adjustable thermostat up to 190 degrees now, and there is an adjustable differential. So you can this is factory set. The first bank of elements is factory set, but it is adjustable. That if the tank drops 2 degrees, my first bank of elements are coming on, or my one bank, whatever you needed for your job there. But I can adjust that up to 20 degrees. So I can make it drop 20 degrees, allow it to drop, say, I have it set for 190. I can let it drop to 170 and turn on. But this DSE and our DVE models with the LCD screens, it can be set so that if I got it set at 180, at 178, it's going to start kicking on elements in the dairy industry, where they are flushing lines and making sure that they have the right hot water. And there's some other benefits of it. There's you can sequence the elements to drop like 2 degrees. First bank comes on, 2 degrees. Second bank, and it drops another 2, and then the third bank will come on. It does have the diagnostics on it as well, and BACnet. Anytime you see a product by A.O. Smith with an LCD screen, there is BACnet options for it. So there is one exception on the heat pump water heater. We don't have it on that, but our electrics generally have BACnet as an option. One last thing here is what I found is which is important when you're dealing with tanks. The advantage of the LCD screen over the surface mounted T-stats is the surface mounted ones, you have to open up the cabinet door and physically change the temperature. You can see the thermostat there. There's a little dial, and they use a screwdriver and they adjust it. But look, there's power wires right there, and I don't know. I sometimes get concerned people might not think to shut the power off before they do that, but whereas the LCD screen, you can change temperature right on the front of the water heater without having to open up the access door or cabinet door. It has the diagnostics, so if one of the elements should burn out, you'll see on that picture on the screen, there's 9 circles. Each one of those would represent an element. And if one of those elements goes out, there'll be a little X through the element, and the heater will go into a mode that will flash and alert the building maintenance people that, hey, there's something, why is my screen flashing on my water heater? It will still continue to heat with the 6 elements or whatever, but it will alert you that one of the elements is out. Whereas the unit with their surface mounted thermostats, the only notice that they would get is that they would just not get the same amount of refresh. It wouldn't heat up as quick as it used to when they need to get a service person in to look at it. So anyhow, move on. I'm gonna go quick over this. So now we know the difference between surface mounted and immersion. The Dell models, Dell 6 and our Dell 20, those are our little short, stocky commercial units. You see the size, 15.5, 21 inches tall. The 6-gallon model is available with up to 3 kilowatts, but the 10, 15, and 20-gallon models are up to 6 kilowatts. So again, using my formula there, they'll heat 24 gallons of water an hour. They're ideal for, say, like the office, kitchen, with a dishwasher type of thing. So they have surface mounted thermostats, and these are available at voltages up to 480. And they're single element, so single phase only. And it is on our spec sheet. So we do have options if you do need 600 volt, 3-phase. You'll see in our DSC models, we do have that covered for you as well. But moving on to the Dell.
Well, we just have a quick question about sizing.
Sure.
I know we're going to go into details, but do you want to just go over sizing briefly here on how to size them?
So yeah, that it will take us beyond our time. That's the only thing.
Yes.
But and maybe we could do another 15-20 minute session if you guys are all right with that. I'd be happy to do that. I do have one like a seminar. We did one for sizing emergency water heaters. We did for restaurants as well, but generally what I have to do with sizing is I commercially I just try to figure out how much hot water they use in an hour. And then I also try to figure out what is the dump load that they're going to try. And dump load would be, hey, if I'm going to fill a 30-gallon sink with hot water, you better have a 30-gallon water heater, right? So right. And when you look at a water heater, we say our Dell 50, for example, or Den 50, it's a 50-gallon water heater. 70% of a tank is usable hot water. So I have a 50-gallon water heater, but only 70% is usable. So I have 35 gallons of usable hot water. So a 50-gallon water heater would be used to fill that 30-gallon sink with hot water. And now I have to ask the question is, how often am I going to dump that 30 gallons of hot water? So if I'm going to do 30 gallons of hot water every hour, then I would take my 30 gallons and divide it by 4.1. My magic is, and I need 7.3 kilowatts to do that job. So you can manually work it out with an electric is pretty easy to figure out, but that's the key is we have to figure out how much hot water you're going to use every hour and what is my largest dump load that I'm going to use. So I quite often use like the Zamboni fill as a good example. If anybody knows what a Zamboni is, they flood the ice. Well, the operator of the ice resurfacing at the Scotiabank Arena, for example, they need to put about 100 gallons of hot water in a Zamboni, and they want to do it quick. So that would be a dump load. I need 100 gallons of hot water. And then I need to, 1 hour later, they're going to reflood the ice again. So I need to reheat 0.1, and that's how I get my kilowatts. So in that case, I would need 25 kilowatts.
And do you always need an expansion tank with any size of water heater?
Absolutely, and that's my very last slide. I'm going to talk about that. It's very
Now,
important.
while we're on the topic of sizing, do you serve hot water heaters based on the fixture units or the Hunter curve?
We don't go by either. Fixture units and Hunter curve are more for instantaneous type water systems. So that's we use the ASHRAE method, and we assign a value of water to a fixture. So for example, we use 5 gallons per hour per lav, and 30 gallons for a single pot sink and 60 for a double, is how we would size it, because with the water heater, you have to remember it's very similar to almost like solar energy. You have a solar panel. You can't try to run an oven off a solar panel. You're just impossible. But what you can do is charge up a bank of batteries and then run your oven. So for a limited time type of thing. So it's very, very similar. So having water in storage does help you get through those sudden high draw demands. So whereas instantaneous, you have to size it really carefully for making sure you have enough capacity to run everything that's going to be on at any given time. So that's the Hunter curve is definitely different sizing method, and the Hunter's curve comes up with way more kilowatts required to do the job than a tank. So putting in a tank type water heater reduces the kilowatt capacity enormously. That's why tank type water heaters still have some advantage over instantaneous. Hopefully I answered that. So from here on in, the 30-gallon Dell and Den models, they are available in 3-phase power. So anytime you got double elements, now you have 3-phase. So the rest of our product is now 3-phase power. Just to warn you, the Space Savers and the little Dell 6 through to 20, they're only single phase water heaters. Yeah. So you need 3-phase, then you need to switch up to possibly a slightly larger water heater. So the spec sheet kind of shows you that when you go to the DuraPower, Dell and Den models. So they are field convertible from phases. So the Dell and Den models, they are shipped, except for, as I said, the 6 and 20 are only single phase. So this doesn't apply for that. But the other models are field convertible from single to 3-phase, just like you would see on electric pumps and so forth. And there's instructions on how to do it in the manual and on the water heater. So it's very simple. Space requirements, we do recommend 30 inches in front of the heater. That would be just to allow the service person access the top of the water heater. I know they're kind of stuck under kitchen sinks and so forth all the time, and they don't have 12 inches on top for service, but we recommend that because there is an anode rod that needs to be checked and so forth. So moving on, the DRE series. This is the general purpose, and I showed you earlier. We have a DRE and a DVE. These are pretty much identical as far as size and heating capacities, but one is surface mount, and we're going to show you the DVE in a minute. So I'm not going to spend too much time on this because we've already talked about the thermostats. They're surface mounted. There's one element or one thermostat per element. So this water heater will have either 3 elements, 6 elements, or 9, depending on what you specify, up to 54 kilowatts. And so there could be 9 of these thermostats in a water heater. We provide the industrial grade Incoloy elements. They're not just a standard copper or zinc plated element. And all of our water heaters, A.L. Smith made a decision back a while ago to include internal element fusing on all of our water heaters, on all of the DEN or DRE and DVE models. And what that internal element fusing does, if one element should go or short out, it'll blow a fuse and take out just that one element, and the heater will most likely continue heating. So we put that. It's also a safety factor. So it's standard on all of our DRE and DVE models. And you can order the DRE series also in ASME certification or certified pressure vessel. So by you just adding an A on the end of your DRE, say 119, it's called a DRE 120, and you would specify what voltage you want based on the spec sheet. So it could be a 54 kilowatt, 208 volt, 3-phase is how you would probably put it. So. And they're also field convertible from phases if it got to site and it was a 3-phase and they only had single phase, or vice versa. They are field convertible, and also several of our models are also convertible in the field as far as the wattage goes. We cannot add more elements to a water heater, but we can change the elements, say from a 2 kilowatt to a 3 kilowatt element, increasing the heating capacity of these. So the DVE model, and I already spoke about this, but if this this might interest you as far as the fact that the customer again doesn't have to open up the cabinet door to change temperatures. They have diagnostics. They have the ability to see runtime history. They can adjust the when they want the temperatures to come on with the TV screen, as I mentioned. They also have a feature that is programmable for off-hour economy use. So like say it's an office building and nobody's in the building from say 6 o'clock at night till 8 o'clock the next morning, they can program this water heater to go into economy mode every day, and even say on weekends it's not used. Why not put it into economy mode on Saturday and Sunday? So now the TV screens here. So we have BACnet options as well, and we do have ASME. So
another question, Will,
Yep.
what are multiple elements that you can describe? So what's the difference between simultaneous and interlock wiring?
Okay, so there's going back to the that would be on our Dell and DEN models. And I'm gonna just go back here on a couple of slides here. So on this wiring diagram here, the Dell and DEN models are set up to and shipped as what I call it is non-simultaneous operation. So a Dell or a DEN model can be available with 2 6 kilowatt elements in it. It would be a 6 kilowatt water heater in non-simultaneous operation. However, this heater is approved to convert it to simultaneous operation, meaning that both elements could potentially heat at the same time. So now you have doubled the heating capacity of that water heater by converting it to simultaneous. And they use the term interlock so they're basically simultaneous or non-simultaneous is really the terms that I like to use. So non-simultaneous, one element at a time will heat, and basically when you fill that water heater with cold water, the thermostat on the top element's going to come on first, and it's going to heat up and only have the top element on until the top element thermostat says, hey, I'm satisfied, it will shut off. But so once it shuts off, then the bottom element will say, hey, I'm still cold down here at the bottom. And what it will do is it will turn that element on. So it will heat the bottom portion and they will both decide to come on and off at the same time. So they could be both running, like say 12 kilowatts, and then the top of the tank gets satisfied first, and then the bottom element will probably continue to stay on for a bit until it's satisfied. So that's basically it. They are you can turn a 6 kilowatt water heater into a 12 kilowatt when you go simultaneous. So you'll see some of the details on that spec sheet there. So anyhow, hopefully I answered that.
Yeah, thank you.
So the DVE, I pretty much kind of covered this. So the screen has some advantages of being able to see what's going on. It's programmable, it's adjustable differential, it has very accurate water temperature control. It has the BACnet capabilities, and there's much more. Even there's a little help button on the screen, and it has some troubleshooting built into it as well, to give the operator some sort of ideas. It keeps track of fault history. If there was ever a power outage in the building, it will keep track of that. It will also, give you, like, say, the runtime, how many hours of operation, days of operation the water heater's been heating as well. So it's and really not a lot more money compared to the DRE, but it's still, there is definitely extra cost involved, and I'll show you why in a minute. I took this picture of I thought it was a beautiful installation here of a job. These are 3 DRE 80 water heaters in there. And if you look closely, you'll see there's a panel like a steel kind of metal door over the front panel there. So if this was a DVE, that would be a screen there. And it's the same tank. DRE and DVE are identical tanks, but before we ship them, we configure them and build them out for your specific job. So if this was a DVE, there wouldn't be a metal panel on that front door. There would be a screen on it, but generally, as a rule, DREs, I find, like in defense of the DRE, not too often do you go and change your water temperatures on a tank. So in this case, it would be just for the use of the office building and general purpose hot water. As long as it's hot, this is doing the job. Anyhow, I wanted to show here this kind of shows some good pictures inside a DRE water heater. On the right side there, you'll see there's 3 elements. So this could be a 9 kilowatt water heater or 6 kilowatt water heater, but we could remove the plugs and put elements in each one of those and make it up to 54 kilowatt water heater. And I just see the styrofoam. We have the styrofoam insulation there, and there's a little styrofoam door that goes over top of that. On the left, you'll see a picture of a Dell thermostat there. And when you go to a DVE model and comparing the DRE, you'll see quite a bit more. There's now magnetic contactors involved, and each one of those elements is monitored by an amp draw. So that's how that works. Somebody left their pliers there on this water heater. So I want to move along here. The DSE models. Now we have our DSE. It's very similar to the DVE, but it's a heavier tank. It's ASME rated, and it's just a different look inside the cabinet door on the DSE. And this could be a 90 kilowatt water heater here. So before going to talk a bit more about the DSEs here, these are our build to order models. So we build them either vertically or horizontally. You'll see it on our spec sheet. and from 150 gallons up to 2,500 gallons, and we can go from 15 kilowatts up to 900 kilowatts. And there's some tank linings. The most popular is our glass line tanks, but you can get cement line tanks as well with this. And really the advantage of the cement line tanks is that they are repairable. So somebody small can get in and reline a cement line tank, whereas a glass line tank is not field repairable. They come with the same Incaloy elements, same kind of control. It's got the TV screen on it, as I spoke about. They're all ASME certified pressure vessels, and we do have several options available. If you look on our spec sheet, you'll see them there with alarm bells and lifting lugs, and we can do different pressure ratings as well. For the tanks, pilot lights, and somebody opens the door, it's going to shut it off, and so forth. So the DSE models, and these are quite common. I kind of find that I use the term industrial grade because they are our heaviest, dutiest tank that we do make. In a stock size. So the DSE 5-gallon model through to 119 or 120 gallon capacities of 3 to 90 kilowatts available. Oh, sorry, little full pot. Oh no, there we go. Standard voltages, we go up to 600 volts. Can be connected to the BMS system. And operating temperatures from 90 to 190 degrees 3-year warranty. So they are a very heavy tank, and you can see by the weight that they're a little bit heavier of a tank than our other models. So this is usually specified when 54 kilowatts is not enough. So as I showed, the DRE and the DVE series that we had in our stock size, they go to 54 kilowatts. So if you needed something more than that, then you can go with the DSE up to 90 kilowatts. So I said 90 kilowatts times that by 4.1. That water heater is going to heat 370 gallons of hot water an hour, roughly. So we do have stock heaters with great heating capacity. And when I say stock, we stock these in Fergus, Ontario. We're generally 5 days to ship something like this. We take the order and it goes to our configuring department, and they configure it before it's shipped to your job. So they're readily available. The custom built DVE 150 to 2,500, those are custom built to order, and I believe they're about 20 weeks lead time for those. So glass versus cement. I get asked this question. Glass is definitely the most popular. It has great bond strength, and I look at it like it's basically an enameled surface like you would see on your kitchen stove or so forth. So I'm sure a little different process, but similar idea to it. It is your best protection against any type of rust or so forth. So the cement line tanks are great if you wanted to keep hot water. I just, my kind of caution on water, and I know in some cases you have no choice but to store really hot water. Our water heaters are all rated up to 180 degree Fahrenheit. Is what we recommend. Anything over that, you're getting close to steam pressure, is very dangerous water. But, just as a scientific note here, water becomes corrosive when it's heated, and depending on the water you're dealing with, the hotter the water, the more corrosive it is. And generally, as a rule, tanks don't last as long in hot water. It's just like hot water expands at a higher rate. It's just more stressful on the metal and so forth. So ideally, we always try to size a water heater to 140 degrees Fahrenheit, and if that's all you need, then that's usually like say how we size a system. So if you go to 160, it is more corrosive on a water heater, and 180 again is even hotter. So the corrosiveness doubles when you increase water every 20 degrees generally. So.
Hey, Will, there's another question that some contractors are saying the glass will break prematurely. What's the lifespan for them?
So that so like a tank failure prematurely, I'm going to talk about that. Let me just finish this one slide, and then I'll just I'm almost done the presentation here, and I want to talk about that portion there. So with our custom DVE and DVE model, the DVE and DHE, those are the 150 gallon to 2,500. There's a bunch of options there, and you can change, the bolt to flanges and so forth. So there's a number of things we can do. We can relocate where you want your cold and hot water to go in, and even locate the relief valve maybe in a different spot because it might be up against a wall or something. So that's stuff that can be done. So we can also put a coil in a DVE and a DHE water heater. So if you wanted to have a backup, like say your heating boilers or so forth, we can build the DVE or DHEs with two bundles in them as well. So there's a picture of DVE 1000, and you can kind of get a perspective of the size of it. So in some cases, we have no choice but to build a round tank versus a square tank, but depends on our manufacturing. They will review your request and come back with drawings at the end there. So the heat water heater, this is a very important part now, as we spoke about here. So the CAHP, it's a commercial air to heat water heat pump. It is meets the ASHRAE 1.8 or 118.1 requirements, but what really becomes important is how much will this heat. So we want to be careful. They're still not meant for that filling that Zamboni and so forth. So when you look at the modes of operation in an efficient mode, in heat pump mode, that's what we mean. Just by heat pump alone, it's going to heat 41 gallons per hour at 100-degree rise. So it has two 6 kilowatt elements in this heater. So that has 12 kilowatts. And as I mentioned, the 12 kilowatts will heat, each element or kilowatt will heat 4.1 gallons of water an hour. So it's going to heat about 50 gallons an hour with the electric element plus your efficiency. That's where we get the hybrid of 90 gallons per hour. That is the maximum you want to go with this type of heater. So it's ideal for like office buildings, where for their labs and kitchen sinks and dishwashers and that sort of thing. Small restaurants, perhaps. So just our sizing program will pick this out. If you go to our ProSize, it will show you what give you some choices as far as product goes. So the sizing program will definitely help you there. But what I wanted to show you is the energy savings here. And this is just an example here. We're going to compare a DRE 120 water heater, which let's just say is 95% efficient. 5% of that heat is lost due to line heat loss and so forth. And let's compare it to a heat pump that has this coefficient of performance of 4.2. So we'll see that on our spec sheet. So that basically means that you get from your same kilowatt, you'll get 4.12 4.2 times more hot water out of that same kilowatt now compared to an electric element. So if we took your local average water temperature of 58 degrees, we're going to say that the heat pump will sometimes 20% of the time it will run in element mode, and our electricity cost is 21.7 cents. So I don't know how we got 21.7, but we did. And your daily hot water demand was 350 gallons per day. We can now easily figure out what the operating cost would be for both heaters. I know that hydro generally sells you at off peak and whatever, but that kind of complicates things. But if we just stuck to one number, you're going to see at the bottom of this, your operating cost savings over 8 years is $28,000. So this is why heat pumps are becoming so popular. Is that, you're not with a heat pump water heater, you're not creating heat, you're just transferring heat from the area. So this is on our pro sizing program. So if you go to our sizing program, just look over to the left side of the screen and you'll see the payback calculator, and you can mess with it there and play around with the numbers to put in different electric costs and so forth. And on our recovery table, you'll just see the electrical characteristics of it. And there's our payback. So you can see the heat pump, it only uses 2.35 kilowatts to produce 41 gallons of water an hour. So if you take 41 gallons, divide it by 4.1, my 1 kilowatt eats 4.1 gallons, you would get 10 kilowatts. So basically, you're heating your water with 2.35 kilowatts instead of 10 kilowatts to give you the same result. So there's our savings. So that, I know that was really quick, and I'm getting long-winded here, but I do want to just answer that question on what makes a water heater fail quicker, and there's several different things, but this is the number one factor that is quite often missed, and I can't stress it enough, is having a thermal expansion tank on your system. All our piping diagrams show it. However, what I did with this diagram, I did add a couple of little things that I think could be added, and maybe on our piping diagrams, but I hope you adapt it into your specs when you're talking about piping diagrams. But just as you know, the science behind water, when you heat water, so like 40 gallons when it's cold of water is 40 gallons. But then when you heat that water to 160, it becomes 41 gallons. Where does that extra 1 gallon of water go? That gets the expanded water. Generally, in older plumbing systems, that expanded 1 gallon would go back to the city supply line and go back, push the water back, and it wouldn't really affect the pressure in your hot water system. But nowadays, everything's got check valves and backflows and stuff. So that extra gallon without an expansion tank is trapped. And what it will do is it will make toilets start to leak or faucets to leak. And if they don't leak, what will happen is you cannot compress water. You cannot. It will belly out the tank. It will expand it. You won't see it because unless you probably put a tape measure on it and saw it, it will expand it. And at some point, the TMP valve, which is rated to 150, will start drizzling water. But we build the tanks, assuming that most of the tanks are used at no more than 80 PSI. They're all tested and pressure tested to 160 PSI. But, they're the ideal operating pressures is under 150. What we don't want to see is a tank going from 20 psi up to 150 psi 100 times a day. That's gonna stretch the tank. It's gonna work the welded joints of the tank. We want to see nice, steady pressure on a water tank consistently. So water hammers, all that sort of thing, are very hard on a pressure vessel, as you can imagine. So we always stress the installation of a thermal expansion tank, properly sized. I use Amtrol sizing program or Watts or whatever, but that I believe ATS can help with the size of that too. And it's also important on how the installer puts it in, because when you buy an expansion tank, they usually only have a pre-charge of 20 psi, and they need the rubber bladder in the expansion tank needs to be pressurized to match the building water pressure. So if it's 60 psi, the rubber bladder or the expansion tank needs to be pumped up to 60 psi to match the water pressure. And that tank needs to be tested every year. So that's why I added in how to put in these shutoffs and drain valves, because you cannot test an expansion tank when there is city water pressure against the rubber bladder. Even if the rubber bladder was completely broken and ripped or rotten, you would still measure 60 psi building pressure without isolating it off. So you have to be able to isolate the expansion tank from the city supply, drain off whatever residual pressure is in there. Now I can measure an expansion tank and make sure it hasn't been compromised. So sometimes you can just use the air valve, the Schrader valve on the expansion tank, and depress it, and you'll know if it's compromised, because water usually squirts out. But that's a key. And all of these water heaters have anode rods in them, and they need to be inspected. I suggest in Toronto market, they do very well, unless they're on really hot water. If you keep water at 160, I mentioned that it gets corrosive. I would give an anode rod 3 to 4 years at 160 before it's depleted. The sacrificial anode rod should be replaced at that point. The DSC model, I didn't mention that, does have a powered anode rod in it, so that the DSC model does have that feature on it. But anodes, soft water, generally people that soften the water, the anode rods deplete quicker, and therefore the anode rods need to be replaced. On soft water, I say every 2 years is probably recommended. Especially water softener companies, they tend to over soften the water, so that does cause the anodes to deplete quickly. But anyhow, I'm done. Sorry, it took so long.
That's okay. Just a few questions here as we finish the presentation, and then I can move on to the quick demo.
Yes.
So the first one, do we need neutralizing kits for electric water heater? The second one, what's the cost difference between the DRE and the CHP? And the last one, if we have multiple water heater tanks in a multi-family building and each with expansion tank, is an expansion tank required at the water incoming to the building after main premise backflow preventer?
Yeah. Okay. So let's the first one is, there is no, for the heat pump water heater, there is no condensate neutralizer required, because it's just basically the heat pump water heater is just taking humidity from the room and collecting it and putting that down the drain. So you definitely have to have a floor drain, all of these heat pump water heaters for sure, right? So and then
second one was the cost difference between the DRE and the CHP.
Yeah. So let's compare sorry, I just want to bring up my my pricing here. Just give me 1 second here. So let's take a DRE 120, or let's take a DVE 120. that's got the computer screen on it, and we'll use the same, say, 12 kilowatts, so we can be really comparative, apples to apples. And so a DVE, sorry, 1 second here. You know, a lot of electric water heaters to go through. Sorry, but I'm there now. So a 12 kilowatt DVE has a list price of $12,284. Let's go and get a CAHP. Almost there. It has a list price of $24,405. Give you an idea. So they're almost twice the price.
Okay. And did
The
you?
expansion- and the expansion tank,
Yes.
we recommend the expansion tank to be on the cold water side. I got the slide here. You really don't want hot water on a rubber bladder. So if you have a recirc, it should be before upstream of where the recirc line enters back in again. However, you know, depending on the expansion tank, it could be located like 20 feet away or whatever. I doubt the hot water will ever get to the rubber bladder because it's not flowing water. So it's always after any check valve, it has to be like nothing between it and the water heater and the hot water system. It's there to protect everything in the downstream of your check valves. So it yeah, you don't want it really after the water heater. You want it before the water heater, ideally in the cold water line. So well, hopefully that helps. We don't really, cold water doesn't expand in the building. So it's really there to protect a water heater from the effects of expansion. So how's that?
Perfect. Thank you. Thanks, Will, for this. What I'll do now is I'm just gonna take over the screen and just show our spec tool quickly and show you where you can find all these water heaters so that you can add them to your next projects. Also, you can always contact us for sizing or for any information. Let me just share here. You just need to stop sharing, Will, so that I can share my screen. Thank you. All right. Okay, so this is main page for the ATS spec tool. As most of you are familiar with it and seen it in the previous seminars that we've held. So we have the quick spec, the projects folder, and you have the master. So the master is your master office that you can build on your own, or we can build for you. We'll maintain the fixtures. We'll keep the same tags that you have internally, and it's only shared with your office engineers. Project, this is usually when you have more than one product, and the good thing is you can copy from the master all the products that you need. Quick spec, we always say, is a one-off product that you just need to add quickly so that you can get the output format. You want the written spec or you want the cut sheet for that product. We also have the ATS templates where you, depending on the project that you're working on, so let's say, for example, you're working on an educational project. If you type in educational, then you will find a template that we've put together for you. Once you click on it, you will see all the different groups that we have available. From the bathroom to the change room to the cafeteria, for example, to the classrooms, and so on. You will have your mechanical room, and this is where you'll find the water heater and the expansion tank as well. What I wanted to do is I just want to show you quickly how you can find the water heaters if you're searching for one. So let's say, for example, we're just looking for a water heater. So if you go to new spec, and we'll do an A.O. Smith test here. And this will take you to the product category page where you'll see all the different categories. If you already know the model number, you can type it here. So we talked about the DVE, for example. The system will look into it and will find all the DVE water heaters that are available so that you can select the one that's that you need for your project and configure it, as you see here. Now, if you're not sure about the model number, for example, and you just want to see all the different water heaters, if you type in water heater, it's gonna find the category for the water heater. Cool feature we have here is you can pin it as a favorite. So if I click on the pin favorite, now when I go back to my categories, I'll see the water heaters all the way on the top here. So let's click on water heaters, and then you will see all the different options that we have on our tool. You can also filter it by the water heater type, by the power type, also by the storage type as well. In terms of sizing, we will have a sizing tool available on the site soon, but for now, we handle the sizing internally. So if you contact us, if you contact me, if you contact your account manager, we'll be more than happy to assist with sizing questions. We usually can go by if you send us the fixture schedule, or if you send us the floor plan, we'll do a full takeoff for you, and we'll select the appropriate water heater products for you. So this is in terms of the selection. So let's say, for example, if I'm going with the Cyclone here, we're one of the most popular water heaters. And then once I select my parameters, I can add it to my spec. The system will ask me usually to select the expansion tank as well. This is part of the smart suggestion tool that we've added to our spec tool. If once you added, so if you're not sure about the expansion tank and the size, we do the sizing. But if you want to have it as a placeholder, you can always go with an unsized selection, just so that you have it as a placeholder on your spec package. Once you've completed the selection, we can click on complete, and it's ready to download basically. So just give it a moment here because I have my videos and everything on. So complete, I have it done, so I can select the drawing, click on download. One thing, a recent change that we've made is now you can actually group your downloads format, so you don't have to select them individually. So let's say I'm looking for my submittal, and I need also the long spec format. I can generate the document, and the system will generate both documents together and prepare them for download. I think there is a question. Let me just go back while this is downloading. Well, there's just a quick question here. What's the max kilowatts of element better to specify for each electric domestic water heater, or just in case the storage tank capacity?
I'm not sure. I always size kilowatts based on the hourly recovery that I want. So like we have our 50-gallon water heater that can take up to 54 kilowatts, and even the DSC I think goes up. So I'm not sure how to actually answer that.
I'll follow up and get more details about the specific case, and we'll see how we can assist. But I just wanted to show quickly here the downloaded format. So we downloaded both. So you have your cut sheets. You can have your head office logo, the project location, and here's the water heater and the expansion tank. And then if I go back, I can open my written spec that we can edit if you need. Any questions? Don't see any other questions. Again, I just wanted to apologize for taking a little bit over, going over the time today, but thank you for joining. We appreciate your support, and if you have any questions, please reach out to me or to Will. I will reach out to everyone individually who has attended the seminar and see if you have any questions that we can assist you with. With that being said, thank you again, and looking forward to seeing you at the next seminar. Thank you, Will. Thanks, everybody.
Thanks for organizing this, Mo. Appreciate it. And thanks everybody for listening.